Okay, let's give you guys some more practice. So in one of the earlier videos, I gave you this and asked you to find out the derivative of this thing here. First, we sketched a graph, and it looks something like this, the reciprocal graph, and then dy by dx will look like this. Will look like this graph here. If you look at this here, the gradient is always negative. So the gradient here is negative. Gradient here is negative. Gradient here is negative. Even when you're in the positive realm, the gradient is negative. The gradient here is negative. The gradient is always negative when it comes to this equation here. So that's why your dy by dx is always in the negative realm here. Okay, it's always in the negative realm. It's negative, 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 and so on. So now the question for this video is find the derivative of this. Okay, so sketch it, and just bear in mind that here the gradient is positive, here the gradient is positive, here the gradient is positive, and then on the right hand side the gradient is negative, the gradient is negative. Just bear that in mind. So if you're when you finish working it out, then your gradient graph should indicate that when x is negative, the gradient should be positive, and on the right, when x is positive, the gradient should be negative. Okay, but well, just so that you have a rough idea of what's going on. Okay, so find the derivative of this, meaning find dy by dx of this. Okay, so yeah, press pause and have a go. Okay, so to do this here, first you would sketch this this graph here, and it looks like this, and then set up your A and B. Set up your A here and your B here, and then say to yourself inside your mind, the gradient that exists between A and B is given by this thing here. But then the true gradient is when you start to decrease h, when you take the limit as h approaches 0. So it will look like this. Remember that our equation was 1 over x squared, positive 1 over x squared. So when you put x plus h into this x here, it would look like this. Okay, and then you've got to take away this, which is, well, the original function here is this here, so you can put it in here. Well, it really dy, the true gradient here, really boils down to you working out the limit of this whole thing here. Okay, so your aim is to find out the limit of this whole thing here. Okay, so the first step is to well, merge these. So here you've got one fraction, take away another fraction, merge these two together, somehow get the two denominators to be the same, and then you can merge the two fractions. Okay, so here you would time, hang on, so here you would, up here you would times top and bottom here by x squared, which is this thing here, times top and bottom by x squared, and then over here times top and bottom here by this thing here, x plus h, and then square it, and then x plus h, and then square it. So overall, this whole thing here will become this here. The good thing is that the two denominators here are the same. So you can merge them. Yeah. So you can merge them, and it will become this here. And whenever you get a fraction within a fraction, visualize it as a over b divided by h. So this thing here gets multiplied to the bottom. So that's why when you're here, the h really boils down to you multiplying it to the bottom. Okay, so that's why the h is here. So this here becomes this, and then what? And then, oh yeah, and then square this, so that will become this whole thing here, and then square this as well. That would then become this. Okay. Well, it's just a matter of simplifying now. Using algebra to simplify. Here you've got x squared, and then you've got minus x squared here. Don't forget this will be minus 2xh, and then this here will become minus h squared. Okay, same with down here. This times this, that will give you this. This times this, that will give you this, and then this times this, that will give you this. Okay, Yeah, that will give you that. And then what? And then factor out the h. So factor out the h, and then later these two will kill off each other, leaving you with this, and then and then start to take the limit as h tends to 0. Well, as h tends to 0, hang on, as h tends to 0, this thing here disappears, and then this, well, you got 0 here times this thing here, so that equals 0. Here you got 0 here times 2 times this, that pretty much goes, and then that leaves you this, and then, well, that divide top and bottom here by x, so that then becomes this here. Okay, so dy by dx, this is your final answer. So when you look at the original graph here, dy, well, when you look at the original graph, y equals 1 over x squared. It's a red line here, and then the gradient graph looks like, well, the blue line's a gradient graph. So look at this here. So you can see here the gradient's positive. That's why the blue line is in the positive realm here. The blue line's in the positive, and then yeah. So here the gradient is negative. So when you look at the blue line, every time you look at the blue line, you've got to get your mind to think in terms of the gradient. So when you look at this here, the blue line represents the gradient, and you can see it is a negative gradient. It's a negative gradient. Let's say now looking at the red line, here the gradient is positive. Well, sorry, the gradient's negative, but it's a shallow negative. So when you look at the gradient graph, you can see it's a negative gradient. It's a negative gradient right here. Okay, and when you're over here, you can see it's a positive gradient. So when you look at the gradient graph, the blue line, it's in the positive realm. Okay, so so this here is your final answer. Okay.